Okay, when you get to deltamath.com, this is what your page should look like. There are two assignments. One is about rounding numbers, and one is about adding and subtracting. Mine shows a 2 out of 10 because I've already tried some, and a 0% because I didn't do any of those. Let's try the first activity. This is about rounding, and sometimes they will tell you how many digits to round to, and sometimes they'll use words for the different rounding number of spaces. So what I've put here is a picture of the names for all of the decimal places. Right in front of the decimal place, we have ones, tens, hundreds, thousands, and so on. Going the other direction, it starts with the tenths, which is like the tens, and goes this way. So sometimes they do it by name, and this is asking us to round to the nearest 100,000th. So 10, 100,000, 10,000th, 100,000th. So the 6, they want us to go 1, 2, 3, 4, 5 decimal places. So on our number, we have 1, 2, 3, 4, 5. We're going to either keep this 1 or raise it up to a 2, and the decider is the 6. The way this works is if the 6 is a 5, 6, 7, 8, or 9, if the deciding digit is 5 or higher, then the 1 will have to bump up to a 2. And if the decider is a 4, 3, 2, 1, or 0, it has to stay at a 1. What's really happening here is we have a 16, and we want to know when we turn the decision digit into a 0, should we be going down to 10 or up to 20? So the 1 was the one that we decided we needed to keep that digit, but we didn't know if we needed to keep it as is or bump it up. So if you think of it, if you know that 16 is closer to 20, you know this is going to round up, but that's how it works with the digit here. So I'm going to type in the entire number until I get to the 1, but instead of a 1, I'm going to make it a 2. I don't type the 0. The zeros and beyond all get dropped unless it's in front of the decimal place. So this is the nearest 100,000th, and then hit submit. And they usually have some pretty good explanations here. They're showing visually that the 2, technically 2, 0, and the 1, 0, our number was a little bit closer to the right-hand side. I'll just do a few more to show some variety. This one's to 4 decimal places, 1, 2, 3, 4. So we're talking about getting out to the 9 and either making it a 9 or a 10, but really it's a 19 or a 20. So if we did bump the 9 up, it would have to go up to 20. So the decider is this 7. 7 is in the 5 and up category, so that is going to bump the 9 up, making the 19 into a 20. So 68.5720. This time we do keep the 0 because we needed the 4 decimal places. Okay, there's a lot of 0.9s in these exercises, and here we're rounding to 1 decimal place, so we're either keeping the 9 or bumping it up to a 10, but it wouldn't actually be a 10, it's really a 39 would bump up to a 40. So let's see if we have to do that or not. So 9 is the one, we want to keep a single digit here, and the deciding factor is this 7. 7 is greater than 5, 5, 6, 7, 8, 9, so that moves the 9 up. When the 9 goes up, you're basically carrying the 1 over to the 3, so that goes to a 4. So from 39 up to 40, so it's going to be 294.0. So instead of 39 or 3.9, it's 4.0. We still have that 1 decimal place. That's why we have the 0. Otherwise, normally we would drop that 0. Again, here's the millionth. Millionths is out 1, 2, 3, 4, 5, 6 decimal places. 775, 278. So we're trying to decide whether to keep the 8 or bump it up to a 9. The decider is always 1 digit to the right. The decision factor is the 0. And since the 0 is a low number, we're going to keep this at an 8. So 4.775278. All right, I wanted to show this one because it's going the other direction. Notice this is thousand, not thousandth. Thousandths are on the decimal side, thousands are over here. So basically, the last digit that can have any value for us would be to the left of this first comma. These three will have to be zeros. And the question is, if we're keeping this digit, that's the thousand, is it going to stay a 1 or go up to a 2? Is it going to be 1, 0, 0, 0? Or is it going to be 2, 0, 0, 0? We will ignore all the rest whenever we're rounding on the left-hand side. So again, the decider is the 7. 7 is a high number, higher than 5. So the 1 will have to bump up to a 2. And we will write 2000 or 2000. We're saying 1756 is closer to 2000 than it is to 1000, which should feel right to you. And again, here is one where we are rounding on the left side of the decimal point. The tens place is this 9. So we know that the 5 will have to turn to a 0 and everything beyond will be ignored. So I'm deciding whether to make it 86990 or round up to the next 10. So the 9 is in question. The 5 tells us that we need to bump up the 9. And again, here's the trick. 9 would go to 10, but this is really 99 going to 100. Actually, it's really 699 going to 700. So when you bump it up, you do really kind of have to carry. So we're talking about 8700, and then the 0 for the 5. And they don't make these problems easy, do they? In this case, I like the graphical view. You can see that 86995 is between 87,000 and 86,990. You can see going up by tens from 90 to 100. Those are the two tens on either side. We were here, which was a little bit closer to 87,000. Okay, whenever you notice that you have gotten your 10 out of 10, you can go back and choose the next exercise, adding and subtracting integers. This little clock, it's a timed exercise, but I don't really care how long it takes you. I put in something like 1,000,000 seconds that you can take. I just can't remove the clock. So hit start. And you do have to get 8 in a row, so be careful. Once you miss one, you have to go back and start counting to the beginning. Positive plus positive is positive. Negative plus negative, you're really adding 6 plus 9, which would be 15, but we're calling it negative 15. Starting with 9 and removing 9, you have nothing left. Okay, when you have a positive and a negative, you could think of it as 8 minus 7, but the larger one is negative, so it's a negative 1, not a positive 1. 4 plus 9 is 13. 2 plus 2 is 4. Again, when they're both negatives and you're adding, it's 7 plus 5 is 12, but the answer is negative. When they're different signs, it's subtraction. The bigger one is positive, so our answer will be positive. In this case, they're both different signs, but the larger one is negative. So I'm subtracting 5 minus 1, but it will be a negative 4, not a positive 4. Let me also illustrate the negative plus positive using the number line. So this is negative 8 plus 6, and I just said that if you have a negative and a positive, the sign of the answer will be the sign of the larger one, which in this case is negative, and you're basically subtracting 8 minus 6. So it should be negative 2, but let's just draw this out on a number line. Okay, so I have a number line here with 0 in the middle, 10 on the right, negative 10 on the left. So 0, 1, 2, 3, 4, 5, and negative 1, negative 2, negative 3, negative 4, and so on. When you think of adding and subtracting, you can think of starting at the 0 point like we do with graphing. And this negative 8 means left 8 units. And then the positive 6 means starting at that point, go right 6 units. And so I think you can see here that if the longer arrow is to the left, I'm going to end up to the left of 0. So my final answer is the same as if I had started at 0 and simply gone left 2. So that's why the answer is -2. It's more negative than it is positive. How much more? Well, it's -2. I also think the number line helps in showing when you're doing two negatives, because first we're going to go left 8, and then we're going to go left 4. And you can see that if you're going left both times, this is the same as going left a large amount. How much? 8 plus 4 is 12, so that's how far to the left we're going. And for my last example of using a negative and a positive, a -1 plus a 3, they're different signs. We're going to subtract. So it could be 3 minus 1, which is 2. But also to show this graphically, it's a left 1, right 3. And that ends up being the same as if I had just started at the middle and gone plus 2. So you can think of it as 3 minus 1 is 2, or you can think of left then right, but the right is bigger than the left. How much bigger? 3 is 2 units bigger than 1, so this could have just gone to the right 2 units. Answer is 2. You can see that you can practice this as much as you want, and I've had people go into the hundreds. It is kind of fun. It does say you do have to stop the timer before going back. Once you go back, you should see that you got a 10 out of 10 and a 100, even though I really got much more than that. And that is part of your homework.